Welcome to section 3.5, and we are going to go through about 26 slides, some of which you are going to need to memorize, or at least be fully aware of the different type of formulas that are here. Now, we are going to substitute values into formulas, and we're giving you these formulas. These formulas will be either three-dimensional, where we're going to give you the formula and you're going to find an unknown variable, but it's the two-dimensional formulas that you are going to have to know. Hopefully you've used some of these in the past. And then there's certain geometry formulas that if you plan to take 470, you kind of want to know. And we're going to talk about the angle measures and finding what we call for a specific variable, which means we're going to be talking about literal. That's an E, that's an A, equations, which means there's not as many numbers as there is letters. Well, here we go. These particular formulas you should know very well, and we're not going to talk about the circumference formula, but you may find it in one or two questions within the homework. And circumference is basically a perimeter of a circle, distance around. And we have, in this case, the area and the perimeter of four-sided figures. We're talking about a polygon, which means the circumference, which is a round figure, is not a polygon. And when you talk about a polygon, the distance around, or add all the sides. An example would be putting fencing around my yard, or putting wallpaper border around my bedroom or a living room. Now, we're also going to talk about area, which is the enclosed space within, in this particular case, within a figure. And when you think of area, think about the carpet in your bedroom or in your living room. To determine how much carpet you need, you're going to find area. Now, if you want to paint a single wall, you're going to have to know the area of that wall to determine how much paint you're going to need. With that said, these next couple of slides should be pretty easy for you. The figure over here is a rectangle. Well, we're going to find the perimeter and we're going to find the area. And these are two formulas that you should know. Now, I'm going to let you know that the capital P, which is going to be indication of perimeter, is equal to length plus width plus length plus width. So that means it's 9 plus 7, but don't forget it's also 9 plus 7 over here, all sides. Well, this will give me 32, 16 plus 16 inches. That's the perimeter. Now, capital A, which is the blue color within the figure, is going to be 7 inches times 9 inches, which means 7 times 9 gives me 63. But you got to remember to multiply the increments, which means we're introducing inches squared. Okay. Now, that's pretty easy. Well, this is what you're going to see. Okay, area of a rectangular garden. Well, right away, notice and remember that the formula is length times width. And a picture of my garden would be length times width. Well, they're telling me that this A is 105. But notice that they want me to do find the length, which means they want me to find L if the width is 7. Well, this is 7 feet times W. Well, remember, this 105 happens to be 105 feet squared. Well, if I divide by 7 feet, notice what's going to happen. I'm going to divide the numbers. 7 divided into 105 is going to give me 15. But think about it. I have 2 feet up here, feet times feet, and I have 1 down here, which means the increment here is going to be feet. This is the length of my picture. And hopefully, this should be something that you can do very easily. Now, we're going to get a little more interesting here. Okay, when you have geometry, you want to try and visualize. That's why in the last problem I drew a picture. Well, here we're going to have to understand, am I using area or perimeter? Well, Mary is putting a wallpaper border at the top of the walls of her baby's bedroom. This sentence sets the stage, and it's telling us that we are talking about perimeter. Because if you put wallpaper, you're putting it around. Distance around. So therefore, let's look at my room. This is length. This is width. Now the first sentence told us perimeter. Now the second sentence says the width of the room, see that little is? That's my equal sign. 2 less than the length. 2 less than the length. Now, if she has 52 feet, now notice feet is not squared. That's another indication you're talking perimeter. This is saying 52 is equal to length plus width plus length plus width. And let me make this a little better here. Length, width, length, width. I'm adding all of the sides. That's what perimeter is. Well, this will give me 4L minus 4 is equal to 52. We'll add 4. I get 56 is equal to 4L. Now be aware that perimeter can have decimals and fractions. But this will give me, when I divide by 4, my length is going to be 14. This is my length, 14 feet. But look at right here. Dimensions. Well, I know my length. What is my width? This is going to get 14 minus 2, or my width is 12 feet. These are the dimensions of the bedroom that Mary is going to put wallpaper around. And if you want to add it together, 14 plus 12 plus 14 plus 12 is going to give me the magic number, 52. I could go back and check this if I want. It works. Okay. Now, another figure that you're going to see is right here. This is a triangle. Now, you are expected to know this formula. Now, remember, perimeter is add all the sides, and a triangle has 3 sides. And the area, well, this has a special formula. It has a fraction, 1/2 the base times the height. Now that means I'm going to multiply the base times 1/2 and then multiply the height. Well, here's my perimeter. Now this will be 10 centimeters, 9 centimeters, 12 centimeters. Now, do you notice that 8 was not used for perimeter? Why wasn't it used? It's not a side. It's not a side. Well, if I add this up, this will give me 31 centimeters. When I add, the increments stay the same, centimeters. Now, area, okay, this is going to involve fractions. 1/2. Now my base is 12. Well, this is 6 times my height. 8 is my height, which is going to give me 48 centimeters squared. And why is it centimeters squared? Because this 12 has the increment of centimeters right here. But 8 also has centimeters. This is 6 centimeters times 8 centimeters is 48 centimeters. This is my area and perimeter of a triangle. And they should be stuff that you should already know. But just in case, I did a little review. Now, volume. In 481, we normally give you formulas for volume. 3-dimensional. Now, when you get to geometry, you may not be as lucky. Some instructors in 470 will give you all of the formulas, some will not. Here, you are using formulas. And there's a little key here. When you talk volume, you're talking 3 dimensions, which is why you see that the exponent on these will be a 3 cubic, okay? And also, volume describes the amount of a substance. Now, substance can be air, it can be water, it can be liquid of any kind, and that volume is measured in quarts, liters, gallons. And here's the way we do it. Length, width, height. Now, sometimes we use the S, and this is the length of a side. Now, the R comes in when we talk about a sphere. And I just want you to know what that R is. Okay. Now, here's some pictures with formulas, but these formulas you won't have to know. Okay. When you talk volume, look at this figure right here. It's length times width times height. This is called a rectangular solid. And then we have the cube. Remember that lovely Rubik's Cube thing? Well, that's where the S comes in sometimes. S is the side, and all of the sides are the same length. Now, we are going to use three-dimensional formulas, and the catch is we're going to evaluate because we're finding a missing value. Okay, and let's look right here. Okay, they're giving us this formula for the volume of a pyramid. You don't have to memorize the formula, but you have to know how to find the missing variable, which is A. Because I have a V, I have a capital A, I have an H. One of those letters I'm going to have to find. Well, I'm told that the V is 60. Okay, this is 1/3. Now I need to find A, but I'm given H. Well, first off, we want to do this. Remember that lovely thing called combined terms? 1/3 times 9 is 3A. This 3 is cross-canceling, and this is going to give me 60. And I'm going to divide by 3. Well, A is going to be 20. Now, sometimes McGraw-Hill wants the word units, okay, because we're dealing with volume. Because the 60 and the 9, we don't know if they're inches, feet, yards, quarts, liters, whatever they are. But normally, the answer 20 will work. Well, now that you understand some basic stuff, let's go a little further. Okay, this is something you do have to memorize. Concepts to know. Now, this is called the angle sum property, which means that you are going to find the sum of the angles, and see that's S, of any triangle is 180. That S is indicating that I have 3 angles. A triangle has 3 angles. So all 3 angles have got to add to 180 degrees. So the magic number to remember when you see triangle is 180. Because here, without knowing that, how do you find the missing angle? And measures mean I want this measure and this measure. But how do I find it? Well, I know that 59 plus 9x minus 3 plus 4x plus 7 has got to equal that magic number of 180. degrees. Well, 59 plus 9x plus 3 plus 4x plus 7 is equal to 180 degrees. We'll combine terms. Remember that lovely stuff we do? 9x and 4x is going to give me 13x. Well, 59 plus 3 plus 7 is giving me 69 is equal to 180. Subtract 69. I get 13x is equal to 111. Now, divide by 13. Well, let's see. I have 9x, 4x, 59. Let's make sure I add them right. Okay, that's 1, 1. Okay. Well, if I take 113, 111, and I divide it by 13, okay, I'm going to get a fraction. Okay. Now, this is where the fun part comes in. Let's make sure I did this right. 9. Oh, get me, get me. I knew something was wrong here. See, that's why I always like to check. Okay. This is supposed to be a minus. See, I forgot that. So that means this is 463, which is 7, 1, 1. Ooh, which means that x is equal to 9. Okay. I thought my problem had to come out to a whole number. Well, see, even I have to go back and check my work. Now, what do I do with that x? This is asking me for the angle. I got x, which means right here, I'm going to put in 9. 9 times 9 minus 3 is 81 minus 3, or 78 degrees. Right here, I'm going to put in my 9. 4 times 9 plus 7, 36 plus 9 is going to give me 43 degrees. See, I got to make sure I write the right number. I knew something wasn't right, but I couldn't figure out why. Okay, well, see, little help from my friends. Okay. Any question? I hope not. Okay, because I'm subtracting 63. Okay, add all of the angles. They have to equal 180. And then, now be careful. I find x, but x is not my angle. I got to put it back in. Okay. Well, let's take a look at the next geometry concept. And most of this you should know pretty well. We are looking at what they call vertical angles. Okay. Now, vertical, do you see this little V? Basically, we are putting two lines and intersecting them, and we're creating V's. this V and this V that I made in red right here. But then notice what's between here and this V is this side. A and C are vertical. B and D are vertical. Vertical angles are equal. And you're going to be given a picture just like this. Well, right away, notice I have this V and I have this V. They are equal. 4x minus 12 is equal to 3x plus 7. I'm going to subtract 3x from both sides. This gives me x minus 12 is 7. Add 12 to both sides. Now, again, I get x. But it's asking me for angle. What do? Where this x is and where this x is, I'm going to do 4 times 19 minus 12, which is 76 minus 12 is 64 degrees. Well, because they're equal, when I put 19 and multiply it by 3, this will give me 57 plus 7. Do you see it is also 64 degrees? If they don't come out to be the same numbers, I've done something wrong. Well, they sure do. They come out to be this wonderful number of 64. Okay? Now, this is our next thing. Now, this is where you got to be careful. A-R-Y. Notice this other word does not have the A-R-Y. Okay. Now, that's where you're going to have to be careful. This is details. Complementary means two angles add to 90. And by the way, if they give you a box, the box is also a geometric symbol for 90. So A and B add to 90. ARY says I have two angles and they add to 90. But notice what happens here. Complement. This is something you're going to have to know algebraically. The complement means take 90 and subtract whatever number you're given. Thus, if I tell you that x is 70, and I want to find the complement of 70, I'm going to take 70, subtract it from 90, and I get 20. But if I'm told that the angle x is 20 and I want its complement, it's 70 because it's 90 minus 20. Complement means take the single angle and subtract it from 90. Okay. We also have this one. Okay. Now, this is where you got to watch. See this word complement? That means we're taking 38 and we're going to subtract it from 90 because the complement is 52 degrees. The complement, take 38, subtract it from 90, and you get your answer. Okay, that's what the complement is. Okay, but I can say that, and just to help you out here, I can say 38 degrees plus 52 degrees are complementary. Okay. Okay. Notice that little word plus. They are complementary. See the ARY? They add to 90. That's what this is interpreting. But the complement of the angle 38 degrees is 52. Notice the difference. If you don't know what the word complement is, looking at that statement, find the complement of an angle is 38 degrees, you're not going to get anything. You don't know what to do. You can look at the question all day long. You got to know what the word, the vocabulary word, means. Now, we're going to go a little further. Okay, here again. Notice what we have. This has got the ARY. Supplementary. Now notice, it's along a line. A line or a linear angle is 180 degrees, or what we call a straight angle. Okay. Angle C plus angle D adds to 180 degrees. But notice what happens over here. Supplement. Okay, this is the phrase you have to know. A supplement is going to give you an angle and ask you to subtract it from 180. That's what the word supplement means. So if I give you an angle of 60 degrees and I want the supplement, I take 180 and I just subtract 60. If I have 120 and I want the supplement of 120, I take 180 and subtract 120 from it, and I get 60. I have to remember, without the ARY, I am subtracting one of the angles. Now, they also get a little more interesting using these words supplement and complement, supplementary and complementary. You are going to need to recognize what these mean, because these story problems, unless you understand the vocabulary, you're not going to be able to solve them. And here is a perfect example, okay? The supplement of 38. Well, remember a couple slides ago we had the complement? Well, supplement means I'm taking 180 and I'm subtracting 38, which is going to give me 142. That is my supplement. Okay? Without knowing what that word supplement means, I can't solve this problem. So complement, supplement. Well, let's get a little more interesting here. Okay, now this is where you're going to really have to watch the words. 3 times the complement of an angle is twice the measure of the angle. Huh? Huh? 3 times the complement of an angle is twice the measure of the angle. Okay. Now, 3 times, see that little word the? That's going to indicate I have a parentheses, which I probably should, because what is complement? 90 minus x is twice the measure of the angle. Is twice the measure of the angle. Okay, 270 minus 3x is equal to 2x. Now this time, I am going to add 3x to 2x, and the reason is this only has one term. I don't want to get rid of it or have a 0 there, okay? This is going to cross out. This will give me 270 is equal to 5x. Divide by 5. X is going to give you 54 degrees. Okay? 54 degrees is the measure of the angle. Okay? Well, let's try this one. Okay, the supplement of an angle. Okay, notice supplement is 68 degrees more than the supplement of the angle. Okay, here we go. The supplement, 180 minus x. Remember that little word is here? 68 more than, okay, see that phrase? Supplement of an angle. Well, let's see what we get here. Well, this is 180 minus x is equal to 180 minus x plus 68. Now, remember we have 3 types of solutions. 3 types of solutions. Well, if I subtract, well, let's do it this way. Let's add these 2 together because I'm going to combine terms. Well, right away, notice what happens if I add x to both sides. What I just did was I now have 180 equals 240. That's not possible. This is a known solution. Can that happen? Oh, yes, it can. Okay. And that is where the fun comes in. We need to make sure that we look at it closely. The supplement. Well, the supplement is this part. We know that's right. Is 68 more than? We got the supplement. That's not going to work. Okay. Now, I'm going to do a little change here. Okay. I am going to create and change this problem a little bit. I'm going to say 3 times the complement of an angle is 68 degrees more than the supplement of the angle. Find the angle. Okay, this time I've made a little change to my problem. Now, last time I had supplement and supplement. Well, this time, this is going to use some really nice stuff. Complement, and it's using supplement. And I do want to let you know that sometimes these problems, if you don't understand the words, you could get a negative answer, but we don't have negative answers, not in geometry. So therefore, I changed the problem a little bit. This should give me 3 times, see that little word the? Now the complement this time is 90 minus x is 68 more than the supplement. And remember, this is my supplement. Slightly different. Well, does this problem have an answer? Well, let's check it out. 270 minus 3x. Now this time I'm combining these two terms, which gives me 480 minus x. Well, this is going to give me a little bit different result because I'm adding x. This will give me 270 minus 2x is equal to 240. 8. Subtract 270. Now, I want to show you something. This is going to give us a negative 2x is equal to a negative 22. This is fine because if I divide by negative 2, I get a positive 11. This may say, well, I don't feel it's right, but it is. Remember, negative divided by negative is positive. Huh? Huh? So is it possible to do some changes? Yeah. But be aware, you are open to having an equation that has a no solution. But you got to remember how to find it. Okay. Now, the last part is the literal. Okay, sometimes we use a formula and you have to find a certain letter. Sometimes we're going to be given an equation and we're going to be solving for a letter. You're still going to be following the order of operations to solve any equation. And as you see, the difference with this, when you're solving for a variable, not a number, a variable, you're going to need to rewrite the formula or the equation, and you're going to be solving it for one of the variables. When you solve for a variable, you're working with what we call a literal equation, because literal means letter. Now we're going to start out kind of nice, and then I'm going to do a little change. Okay, this is asking me to solve for x. Nothing new. We've done this. And notice this has only one variable. I'm solving for it. Well, if I subtract 9, I get 2x. This is going to cancel out. 8. And I'm dividing by 2. And I get x is equal to 4. I have solved for x. Now notice what I did. I subtracted. I then divided. Because remember, Aunt Sally makes dumplings. Well, now notice how this is going to change. Okay, look right here. I don't have any numbers here, but it shouldn't surprise you. I want to solve for x. So instead of having 2x plus 9 is equal to 17, I have kx plus c is equal to m. What's the first thing I'm going to do? I'm going to subtract c. Now, this is going to give me kx. This is going to cancel. But now this is a little different. This is m minus c. I'm showing the subtraction. And if you remember, the next step was to divide. Well, I'm still going to divide. I'm going to draw the fraction bar, and I'm putting k here. This will give me x because the k's are going to cancel. But what I get here is I get m minus c divided by k. This is solving for the indicated variable. It's just thinking of it as k was a 2, and m was a 17, and c was 9. The only difference is right here. I can't get a number here. I got to keep the fact that I subtracted. Now, we're going to have a little more interesting one. Okay, we want to get t. Okay, we are going to do this in pieces so that you understand. The first thing we're going to do is get rid of that fraction, which means we're going to multiply both sides by 2. That means this side is going to multiply by 2, but that y has to be multiplied by 2. So I now get 2y, this 1/2 and this 2 are going to cancel, and I'm left with t n squared. Well, I want to get rid of this because I want t all by itself, 4t. Well, what am I going to do? I'm going to divide by n squared. Which means this t is going to give me 2y divided by n squared. This is for my indicated variable. Very easily done. Aunt Sally makes dumplings. Or David makes dumplings, because I got to get rid of the fraction first. Now, this is our last one for today in this section. Okay, first off, we want to get this term inside of the parentheses. Well, just like before, I have this fraction right here. That means I'm going to multiply both sides by 4. This will give me 4c is equal to n, I still have the parentheses, a sub 1 plus a sub 2. I get rid of the fraction. Well, now, what do I got to do next? This n is next to a parentheses. I'm going to divide by n. Well, what does this leave me with? 4c over n. But now all I have is the parentheses, and it's gone. And the last thing I'm going to do is subtract. I'm subtracting a sub 2 from both sides. Well, what is this going to give me? Well, over here, I have 4c minus n, or divided by n, minus a sub 2. And what do I have left on the right? A sub 1. This is what I want to solve for. I get rid of the fractions. I then have to get rid of the n, which is in front of the parentheses. And then I am left with only the parentheses. So I subtract. This is the end of 3.6 or 3.5, my lovely geometry problems. Do take care, and I will see you again. Okay?